Hi, my name is Napol Rachatasumrit. Today I'll be presenting highlights from our work on Forsense, a browser extension for improving people's online research. In the past couple of decades, the internet has become an essential tool for people to access information and conduct research. In 2018, the data from Pew Research Center said that 96% of adults in the US rely on online searches to make big decisions, and we can still see similar stats today. Sometimes we only need to find an answer to a particular question, like what is the address of the restaurant, but many times there is no one clear single answer, like which car to buy or how to build a computer. And the focus of this work will be on the latter. Unlike the question answering task, this kind of exploratory research is very complex and requires a significant amount of cognitive effort. It usually involves going back and forth between different tasks multiple times. Even though there are different tools that help people in gathering or organizing information, the process usually involves moving information across many fragmented tools that cause distraction and information loss. Our goal is to improve the efficiency of the web browser-based online research experience by leveraging sensemaking theory and modern machine reading capabilities. We see the opportunities to improve online research tasks by framing them as an integrated sensemaking experience. We can separate the online research into two interconnected activity loops, foraging and sensemaking. During the foraging, people search and collect information from various sources, while in the sensemaking, people form a schema of the information they collected. During the research process, people iterate through these loops multiple times and usually go back and forth between them repeatedly. This framework highlights the importance of an integrated tool that lets people seamlessly alternate between two stages when doing research. We argue that such integration leads to less fragmented experiences with less distraction arising from context or application switching. The framework also brings attention to potential machine supports for both foraging and sensemaking across different stages in the process. In this project, we use BERT, which is a transformer machine learning model, in order to encode text input into a numerical vector representation called embedding. Then we can compare semantic similarity between two pieces of text by looking at the distance between their embeddings. With a sensemaking theory as a design framework, our design goal is to support the iterative nature of online research, including the frequent activity switching between foraging and sensemaking, and incorporate unintrusive machine support to the process. We presented the following 4 design principles to guide our system design. First, our system will use a smaller unit of analysis, such as a paragraph of text instead of the whole web page. We believe these smaller chunks are more semantically coherent, that would be more useful for schematization and machine support. Second, we aim to explore opportunities to leverage modern machine reading capabilities for the system to be able to support online research. Third, we want to eliminate the cognitive loads from fragmented tools by providing an integrated experiences that make it easy to navigate between foraging and sensemaking activities. Lastly, the machine supports can be unhelpful and incorrect at times, so it is important for our system to give people abilities to recover from those errors easily. In order to assess the effectiveness of our approach, we built a design probe to explore and gain insights into the opportunities to improve online research using current advances in machine reading, the benefits of integrating multiple stages of online research in the same tool, and the effective strategies for handling imprecise machine suggestions. The goal of a design probe is not to argue that our approach is superior or quantitatively measure the effectiveness of the users, but it focuses on the insights that we can learn through observing users interacting with the system. We have built Forsense, a browser extension that supports and improves the online research experience. It consists of the browser extension and server components. We focus on the browser extension in this presentation, but more information about the server components can be found in the paper. The first component of the extension is the clip sidebar that supports foraging activities. It allows users to highlight interesting parts of the web pages and collect them as clips. The sidebar will act as a shoebox and keeps a collection of clips that users collected. Users can also assign clips to a different group. Once groups are created with clips in them, the system will use the embeddings of clips in the group to calculate and suggest relevant clips in the web page. Then users can either accept or ignore those suggestions by clicking on the icon next to the suggestion. Users then can switch to the sensemaking canvas by clicking on the canvas button in the icon. The sensemaking canvas is where users can organize clips into different groups and specially arrange them to make sense of the topic. The groups that were created here will also be represented in the sidebar, using the group color on the left of the clip. On the other hand, when you add a clip to a group in the sidebar, The clip will also automatically put in the group on the canvas. Similar to the paragraph suggestion in the sidebar, Forsense will use embeddings of clips in the group to provide auto group capability. Users can hover on the auto group button in order to see the suggestion of a group that the clip might belong to. The clip will be automatically put in the suggested group when users click on the button, and they can also undo it if they change their mind. We then conduct a user study with Forsense as a design probe to gain insight into our research questions. In our user study, we recruited 10 participants with a diverse background, ranging from designers, PMs, engineers, and researchers. Our study sessions start with a quick video tutorial of the system, and then we let the participant practice using the system for 10 minutes. After that, we ask the participant to conduct online research in order to prepare an outline for an introductory presentation about a topic. The participant can choose a topic from the list that we provided, but they also can come up with their own topic. The topics are very diverse in order to make sure that the participant does not have prior knowledge. After 30 minutes of research, we ask the participant to create a presentation outline for 10 minutes. Finally, we conduct a survey and semi-structured interview about their experience with the system. In the next session, we will discuss the result and main insights from our study. Overall, the participants found Forsense to be easy to use with a mean SUS score of 72.3. On average, there are 5 groups created with around 3 clips per group. Our first research question is to explore how do people benefit from the machine support. We found that these clip suggestions, while sometimes not accurate, can still be beneficial for users. Usually participants will skim quickly through a website and could miss some of the relevant sections. These suggestions would bring their focus to those sections. Even when the suggestions were imperfect, the participants would try to recognize the connections and use them as inspiration to explore deeper. And also, since these suggestions are easy to disregard or undo, it does become less critical even when they are not totally accurate. Our second research question is how useful is the integration of foraging and sense-making activities in a single system. The findings show that the integration does in fact help users to be more efficient and reduce distractions from moving between apps and allow them to stay in the flow during their research. For example, participants like the ability to assign clips to groups without having to pause their foraging and switch to the canvas view or the other apps. They also like the canvas as a way to externalize their current mental model, test it, and refine it. Our last research question is to explore the effective strategies for handling imprecise machine supports. We found that participants often form a mental model about how the system works and how they can affect it through the interaction with the system. When we let participants initiate the machine support by first creating groups themselves, they become more forgiving to the incorrect suggestions. Sometimes they even rationalize the suggestions that they do not agree with and try to think about how they can improve them. Many participants also express the desire to have more options to fix the incorrect suggestions. For example, the ability to highlight part of the clips that is relevant or provide related keywords for a group. Based on the findings, we identify a couple of key design recommendations to incorporate machine support in online research systems. First, imprecise machine support is more useful than we expected, especially when it's not critical. It can help users reevaluate their perspectives on the topic and explore more diverse information. Next is to use short clips as a unit of information instead of a whole web page. They allow participants to be more expressive in the way they build their understanding about the topic. These clips are also more manageable and more semantically coherent compared to a web page. The third recommendation is to identify and design for these teaching moments in this intelligent system. More expressive ways to teach the system or correct the mistakes are welcomed by the users and can help increase personalization. Finally, we think it would be useful to think about complementing before thinking about collaborating in the human-AI team. This perspective helps relax our expectation on the system and focus on how a person's capabilities can be augmented instead of replaced by an AI. To recap, in this work we aim to improve an experience for online research, which is a crucial task, but also quite difficult because of its complexity and fragmentation in the current toolsets. Inspired by Sensemaking Theory, we have designed Forsense, a browser extension that supports the experience by integrating foraging and sensemaking activities and increasing machine agency through machine reading. We use Forsense as a design probe to gain insights into how people will interact with such a system. Main insights from our study include machine support can help accelerate the process, and seamless integration between two stages reduce distraction and help users stay in the flow. We also found that even imperfect machine interventions could be useful, as participants sometimes welcome them as inspiration to explore deeper. Finally, this work would not have been possible without my co-authors, my mentor Gonzalo, and my collaborators Jina, Rachel, and Chris. Thank you for listening to our talk.